Hi, welcome to the Olympiad Geometry Club. Let's continue our study on the geometry treasure. Because some personal issue, I stopped recording the video for about a year, and now I want to continue this project. And let's start. Today we're going to talk about the Steiner Lehmus theorem. It's a very interesting problem. So in the triangle ABC, the angle bisector of angle A and angle B intersect opposite sides on points DE. If AD equals to BE, then angle A equals to angle B. Sounds like a very simple problem, but if we let's just draw the figure here. I will have A, B, C. We know the angle bisector of angle A and angle bisector of angle B intersect the opposite sides on point D and E. So the problem set is that if AD equals to BE, we want to prove angle A equals to angle B. Right. So let's consider another case that if angle A equals to angle B, it's extremely easy to prove that AD equals to BE, because we can just prove that triangle ABE and triangle ABD are congruent. But for the case that AD equals to BE, we want to prove that angle A equals to angle B. It's not that easy. So here I want to show two methods. In the book, in the geometry treasure book, the author lists about 42 methods, different methods. I read all of them, but I don't think that the audience would be interested to watch a video that includes like 42 methods. So I'll show just two methods. The first method would be my personal method. I didn't find it actually on that 42. If I remember correctly, I read this long before. But let's say the first one is my personal solving method, and the second one would be the simplest method from for this problem. Okay, so let's start. The first one, if we look at the problem set, that if AD equals to BE, we want to prove that angle A equals to angle B. Right, AD equals to BE. That's the only problem set we get here. And also AD and BE are the angle bisector. So my method is pretty force brutal, because we already know that this is a triangle. We know the side of the BC. We can represent it as letter A, and AB should be C, AC should be B. So we can just calculate for the AD and BE and compare these two and prove that if AD equals to BE, then B must equal to A, right? So let's calculate for BE squared. If you remember the square root theorem, BE squared equals to BC squared times EA divided by AC plus AB squared times EC divided by AC, and minus AC squared times EC divided by AC times AE divided by AC. Right, that's how we calculate the B squared, and this equals to, so BC squared, that's A squared times EA to AC, EA to AC. We know that BE is the angle bisector of angle B, so AE to AC would be AB to AB plus BC, which is C divided by A plus C. And similarly, AB squared, that is C squared times EC to AC. EC to AC would be a divided by a plus c minus ac squared, which is b squared times ec to ac, which is a to a plus c times c to ae to ac, that's c to a plus c. So we can simplify this one, so it equals to ac, right? Because this one is we can extract ac out, so we left a here, we left c here, and a plus c divided by a plus c, that's 1, so ac we can extract out. For this one we can extract out as well, so it eventually comes to ac times 1 minus b squared divided by a plus c squared, right? So that's for be squared. So similarly, we can calculate for AD squared. AD, look at this one, BE squared. The opposite side for the angle B is B here, which occurs here, right? So for AD squared, the opposite side is the opposite side of the angle A is A here. So we can directly write it as BC 1 minus A squared divided by B plus C squared. Right? So we know the problem set that AD equals to BE. Let's say if so we know let's say it this way. We know that we know that AD equals to BE, right? So that means AC times 1 minus B squared to A plus C squared equals to BC 1 minus A squared to B plus C squared. Right, we know this is true. So let's say if AB larger than BC, right? If AC is larger than BC, right? Because we want to prove that angle A equals to angle B, which means that we want to prove AC equals to BC. So if AC is larger than BC, which means B is larger than A, then we can try to see if this is still valid, right? B is larger than A. Then we know that B divided by A plus C should be larger than A divided by B plus C, right? Because B is larger than A and B plus C is larger than A plus C. So B to A plus C should be larger than A to B plus C, which means 1 minus B to A plus C should be smaller than 1 minus square should be smaller than 1 minus A to B plus C squared, right? And then we know that because A is smaller than B, A times 1 minus B to A plus C squared should be smaller than B times 1 minus A to B plus C squared. Right, so that is saying if AC does not equal to BC, we won't have BE equals to AD. So BE equals to AD, false AC equals to BC, which means the angle A equals to angle B. That's my method. You can see this is a pretty analytic method. We can just have the problem set here and false brutal calculate it and use the problem set to have a conclusion that A and B false to be equal. And I want to show you another method, which is a pure geometric method. So let's reconsider about the problem here. we have triangle ABC here, and let's just assume, okay, just assume that angle A is larger than angle B. Okay, because angle A is larger than angle B, so we know that BC is larger than AC. Right, we still have the angle bisector here. Still have angle bisector here. D, E. This point is P. So we know that half of angle A is larger than half of angle B. So we can find this angle. We set it as half of angle B. Right? We know that half of angle A is larger than half of angle B, so we can find this half of angle B here. Then we know that, let's set this as M, this as N. Then we know that the triangle, because this is half of angle B, this is half of angle B, right? So we know that triangle NAD is similar to triangle NBM, right? Because the angle NAD equals to angle NBM, and angle AND equals to angle AND equals to angle BNM. So the triangle NAD is similar to triangle NBM. And let's see, we also know that BD equals to AD equals to BE, right? Which means that BM is smaller than AD. Right? And because BM is smaller than AD, look at the triangle NAD and NBM. Because BM is smaller than AD, so we know that BN is smaller than AN. Right? BN is smaller than AN, which means the angle AN opposite to is angle ABN should be larger than the angle BN opposite to, right, which is angle NAB. And what is angle ABN? ABN is half of angle B plus half of angle B. Should be larger than, what is angle NAB? That's half of angle B plus half of angle A. So we get angle B is larger than angle A, which is conflicted to our assumption. That means this assumption is not valid. Eventually we get that angle B equals to angle A, right? So basically you can think about that we can set angle A larger or equals to angle B, and eventually we get angle B larger or equals to angle A. Then the only condition that meets these two requirements would be angle B equals to angle A. Okay, that's the simplest way to solve this problem. It's amazing that it looks like a very simple problem, but it's actually not. And people find like more than 40 methods in just this one problem. It's really, really fascinating. If you want me to make more videos on this particular problem, just or you want to know like more methods, more interesting methods, just send me an email. I can give you some answers on that, but I don't want to make a very long video for like 42 methods. Okay, that's today's video. Thank you. If you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. See you in next one.